Namaste children. Next we are going to discuss about the first law of thermodynamics. It is a common experience that energy cannot be generated without consuming energy of some other kind. If a certain amount of one kind of energy is produced, an equal amount of some other kind of energy will disappear, so that the total energy of the universe remains constant. So this is actually the basis of first law of thermodynamics, which is also known as the law of conservation of energy. This law, that is the first law of thermodynamics, states that energy can neither be created nor destroyed, although it may be changed from one form to another. So from this statement, it is clear that the total energy of the universe, that is a system and the surroundings taken together, is always constant during any physical or chemical process. So let us go in detail. The first law of thermodynamics. Here you can see the internal energy is taken as UA. Before the system is absorbing any amount of energy, heat energy, or doing any work on it. So before absorbing energy or before doing any work, let the system have an energy UA. And you want to change this internal energy of the system. So how can you change this internal energy of the system? There are three possible ways to change the U, or the internal energy of a system. Heat passes into or out of the system. That is, the system can absorb energy or release energy. That is one way. Second way, work can be done on the piston or by a system. That is, if you are taking a piston, a vessel fitted with a movable piston, if the piston is moving down and if there is a gas inside the vessel, if the piston is moving down, means work is done on the system. If expansion of gas is taking place, means the piston is moving upwards, then what is happening? The work is done by the system. That is, the system is moving, that piston is moving upwards. So that is the second point written here, work done on or by the system. Third, matter enters or leaves the system. If it is an open system, the matter can enter or leave the system, otherwise not. For a closed system, delta U, that is a change in internal energy. That is the final. That is here you have, as you can see here, UA is the beginning, internal energy system in the beginning. Consider the final change would be UB. Then UB minus UA, that is a change in energy. Final minus initial is the change in internal energy, which is represented as delta U, as you can see here. Q is the heat absorbed or evolved. Heat is actually represented as Q. So Q can be heat absorbed by the system or evolved or liberated by the system. W is the work done. It can be on the system or by the system. So for closed system, there is no matter exchange. So matter is not entering or leaving the system, which we have learned earlier. Next, internal energy after absorbing the Q amount of heat or evolving the Q amount of heat, let it be UB. So let me make it more clear. That is, consider a system with internal energy UA, which you have learned earlier, and that system is absorbing Q amount of heat energy. Imagine that system is absorbing Q amount of heat energy. So it becomes UA plus Q. If it is absorbing Q amount of energy to UA, then it becomes UA plus Q. Now consider W amount of work be done on it. That is, on the system you are doing W amount of work. So that the internal energy UA is changing to UB. You can see here on the screen, it is becoming UB. So it becomes the final UB is equal to UA, which was the initial energy UA plus Q plus W. So final energy UB becomes UA plus Q, because it is absorbing Q amount of heat energy, plus W amount of work is done. So UB is equal to, final UB is equal to UA plus Q plus W. So what would be UB minus UA? That would be equal to Q plus W. UB minus UA is Q plus W, or difference in energy is delta U, change in internal energy, would be equal to Q plus W. That is, change in internal energy delta U is equal to heat absorbed plus work done on the system. So this is the basic thing that you have to understand, children. You can write these details in your notebook because this is not shown here. It is for you to understand that I have explained. So this is what I have written. Final is UB minus UA, which is delta U. So change in internal energy is equal to heat absorbed, because UA is absorbing Q amount of heat energy and W amount of work is done. For example, if it is W, then the change in internal energy UB minus UA is equal to Q plus W. The equation is a mathematical statement of first law of thermodynamics. So this is the mathematical statement, and we have problems also to do based on first law of thermodynamics. So first law of thermodynamics states that energy lost in one form results in the energy reappearing in the another form. That is, energy is conserved. The statement which I have explained earlier also. In other words, the total energy of an isolated system is a constant. So this is actually the first law of thermodynamics.